Alright, here we are, Algebra 2, Chapter 9. And we are looking at today ellipses. Okay, now an ellipse, the way an ellipse works is it has two foci. So we have two points, and those are your foci. And if I were to draw, or if I were to have a string that I had that was a little bit longer than the distance between these foci, and I was to put my pencil in that string, and I was to draw around, and the string would follow my pencil like this, and it would go around, and my pencil would, I would just hold it, and the string would be, my pencil would hold the string tight. And if I were to go around like that, then my pencil would draw an ellipse. So that's that's one way to draw an ellipse here, is if I had a piece of string, tied it to two nails, and kind of brought my pencil taut on that string, I would draw an ellipse. And so that's what these foci are, and that's the ellipse. So let's get into learning. Let's see, let's write, these are foci. Something about an ellipse. So this stuff is pretty new for you guys, I think. So what I'm going to have you guys do first is I have a bunch of notes on the ellipse for you to copy down, and then I am going to explain it. So you don't have to sit on the video and watch me write it all. Go ahead and just pause this and write it all down, and then I will start explaining to you once you have unpaused. So go ahead and pause now. Okay, so hopefully you can see enough to copy this down. So what we're doing here is we have two forms of the ellipse. So one is horizontal or squished, flat, and then one is more vertical, which is squished on its sides to go up and down in that fashion. And so in this case, this A length here is the longer length, and so notice how the A is with the x fraction. So since A is here with the x fraction, and A is the longer length, then I know that my ellipse is going to be flat, horizontally stretched this way. In this case, over here on the right, you can see the A is the longer section here, and it is with the y value in the fraction that has the y value. And so you can see the A is the longer one, and that's from the center to the vertex. So if you go from the center to the vertex, whichever one is longer, if it's the x is longer, then you're using this form, and the ellipse is flat this way. If the A is longer and it is with the y fraction, then you know the ellipse is going to be taller. Now let's talk about what some of these letters mean. Alright, so this V1 and V2, these are the vertices. And notice how they are on the edges along with the A. So the vertex 1 and vertex 2 here, those are along the major axis. The major axis. And this major axis is a line that goes through the vertex, the center, the foci, and the other vertex. Goes through all of those. The major axis is the one that goes along the longer part of the ellipse. Now the shorter side, the shorter part of the ellipse, has co-vertices. So these co-vertices, the minor axis goes through the co-vertices, and the center here, center C. Now, the length from the center to the vertex is A. Center to the vertex is A. The length from the center to the co-vertex is B. From the center to the co-vertex is B. Same with this ellipse. I'm just using this one over here. The length from the focus to the center is this little c. All right, did I talk about each thing? Major vertex, minor vertex, vertices, co-vertices. Okay, good. Now, H is the x value of the center. K is the y value of the center. And I think that is everything here. All right, now you've got all of this mess here, all of this jargon, and it's all good stuff. But a lot of it we're not totally going to use. We're going to use them in concept, but we might not write h plus or minus a, k, when we find our vertices. You'll see as we do some examples here. Now, one thing you might have missed down here at the bottom, I don't know if it showed up here, but a is greater than b in this ABC relationship. So c squared equals a squared minus b squared. C equals the square root of a squared minus b squared, and a is greater than b. So we're going to use this as we graph these things. Okay, there we go. Now let's get right into an example. So we're going to graph an ellipse. Already? What? We just started this. Yes, we're going to graph one. All right, so I've got x minus 3 squared over 36 plus y plus 1 squared over 9 equals 1. Notice how it says equals 1. An ellipse is going to be equals 1. If you got equals something else, you got to figure out what's going on. Something else is going on here. All right? Now, the first thing I look at is which one of these is bigger. So 36 is greater than 9. That means, and so notice how it's with the x value. So that means I'm going to have an ellipse that is squished and elongated horizontally. So I already know a little bit of what my ellipse is going to look like. And I'm just going to start drawing this thing so that I can see what's going on here. So my vertex is, or my center, I should say. Sorry, I shouldn't say vertex. My center is 3, positive 3, negative 1. 3, negative 1. Notice I take the opposite of what I see here because my standard form shows that it's x minus h, y minus k. And so I need to switch my signs here to have that be correct. So I'm going to draw my grid here with fairly large distances between here. So my center is 3, negative 1. 1, 2, 3, negative 1. There's my center. All right. Now I need to find my a value and my b value. So this one is going to give me my a value. This one is going to give me my b value. So a squared equals 36. B squared equals 9. So I'm going to take the square root of both of those. A equals 6. Square root of both of those. B equals 3. So I'm going to, my a value is with x. So I'm going to go along the x-axis. 6. I'm going to go 6. 1, 2, 3, 4, 5, 6. There's one vertex. And then I'm going to go to the right. 1, 2, 3, 4, 5, 6. To the right, there's my other vertex. All right, so my distance there is 6. So I have my vertex V1 is going to be 1, 2, 3, negative 1. Vertex 2 is going to be let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, negative 1. All right, so now I'm missing just a couple more things. Let's check B here. So B is going to be up and down. 1, 2, 3. And down 1, 2, 3. So my covertice is going to be 3, 2. And my other covertice is going to be 3. And then I'm going to have, what is that, negative 4. Then I'm going to draw my ellipse. Looks pretty good. Okay, and there's one thing I'm missing, and that's my foci. I'm missing my foci. And so that I need to find my C value. So remember, C squared equals A squared minus B squared, and A is the bigger number, right? So I've got A squared, 6 squared is 36, minus B squared, which is 9. So C squared equals 36 minus 9, it's not 25, it's 27, right? Take the square root of both of those. And so C equals the 3 square root of 3, right? Because 9 times 3 is 27. Square root of 9 is 3. So 3 square root of 3, which is about 5.2 if we were to put that in our calculator. So that means 5.2 spaces from C, from the center, is going to get me my foci. So I go 1, 2, 3, 4, 5.2. Right there, and 1, 2, 3, 4, 5.2 right there. Those are my foci. And if I were to add, so my center is 3, negative 1, right? So I can find this foci is 3 plus 5.2, so that is 8.2, negative 1. And my other foci, focus here is 3 minus 5.2, so that'll give me, what is that, negative 1, negative 2.2, and negative 1. There we go. Uh, 8.2. I feel like I did something wrong. Okay, anyway, here we go. Let's do one more example, and that will be all of the ellipses we are going to look at. Let's find that one example. Here it is. X plus 2 squared over 9 plus y minus 1 squared over 4 equals 1. So I've got equals 1. I'm looking here, I see that 9 is bigger than 4, so again I have the same situation where my ellipse is going to be flat that way. This is going to be like horizontal orientation. Oh, one thing we didn't do here is we didn't list our major and minor axis. So let's do that really quick on this example back here. So I've got, for this axis, goes through negative 1 here. So my major axis is y equals negative 1. My minor axis is right here, and that goes through x equals 3. So x equals 3 is my minor axis and my major axis. So we didn't label those, but there they are. All right, let's go ahead and do this one. So a squared gets me 9, so a is 3. 4, the square root of 4 is going to give me what b is, so b is 2. All right, and so we can start graphing this thing. my center is -2, 1. Back 2, up 1. There's my center. And my A value is 3, so I go 1, 2, 3. There's A. 1, 2, 3. There's a vertex, and here's another vertex. Alright, and then B is 2, so I go up 2, 1, 2. There's my co-vertex, and then here is my other co-vertex, down 2. And I'm going to draw my ellipse. There it is. We can label these points here. This is 1, 1. This one is -2, positive 3. This vertex here is -1, 2, 3, 4, 5, 1. And this co-vertex here is -2, -1. My center I've already listed over here. My major axis is the longer one here, so that's y equals 1. Goes right through here, right through 1. My minor axis right here is -2, x equals -2. Notice how I am writing them in form of a line, x equals -2, because it is a line that goes through there. There's my axis. Okay, now I need my foci. And so c squared equals a squared, which is 9, minus b squared, which is 4. C squared equals 5. So c equals the square root of 5. What is the square root of 5? 2 point something, right? So I take the square root of 5 and I get let's say it's about 2.2. So I go this way 2.2, there's one foci or focus, and then I go to the right 1, 2.2, and there's my other focus. So this one is going to be 0.2, 1, and then this focus here is going to be 1, 2, 3, 4.2, 1. And we have graphed another ellipse. 2 ellipses in one day? Crazy. All right, now let's do some other kind of examples here where we are going to write equations based on information. Are we going to do that? Shoot. Yeah, let's do it. So we're going to write an equation. So we're given some information. So we're going to say, okay, my major axis is from -6, 2 to -6, -8. So that's my major axis. And my minor axis is from -3, -3 to -9, -3. All right, so we're going to take this information and we're going to write the equation of the ellipse using just this information. So the way I do this is I start sketching this out a little bit so that I can see what's happening. Otherwise, it's a little bit more difficult to figure this out. So I'm going to start drawing this. So at -6, +2, 1, 2, 3, 4, 5, 6, and then +2, there is one vertex. And my major axis is going this direction. -6, oh, not that direction, no it's not. -6, -8. -6, 1, 2, 3, 4, 5, 6, 7, 8. That is where my point is. So this is my major axis, right, from here to here. All right, now my minor axis is -3, -3, 1, 2, 3, 1, 2, 3, right there, to -9. So this is 6, 7, 8, 9, and down here to -3. So there's my minor axis, or the shorter one, right? Okay. So my ellipse looks like this. And if you're really clean with these notations, you can just count to find the information that you need. So right here is my center. My center is negative 1, 2, 3, 4, 5, 6, and negative 1, 2, 3. -6, -3. Notice how the x value for both of these is -6. The y value for both of these is -3. So I can put the 3 there and the -6 there. There we go. I have the center. That's another way to do it. And so if I was to write out my parabola here, I know I'm going to have my y value is going to be here. Or actually, we can put it, it doesn't really matter, but we'll put it here. Y plus 3 and x plus 6. So I just reverse those, I switch those signs. And now I need to decide which one of these is a and b, and I say equals 1. And what do I do down here? So the distance from here to here is 3. So, because this is 6 and this is 9, so this is 3. And the distance from here to here is halfway there is 5. Right? Yeah. So that distance is 5. 1, 2, 3, 4, 5. So the bigger one is my a value, and that goes with the y because this is oriented this way, is it's taller instead of fatter or wider. So a squared is 25. B squared is 9. And that's all I need to draw my to write my equation. All right. Next, let's do a couple more of these. Probably 2 more. All right, so I've got the vertices are at -4, 4, and 6, 4. And the foci are at -2, 4, and 4, 4.